Good afternoon. Today I will work through the first part of the 2018 paper 2 calculator paper. Then at the end, please go and try the questions that I've provided that match up with these type of questions, and then remember there will be a part 2 video where you will work through the rest of 2018 paper 2. Right, let's make a start. Right, okay. Households in a city produce a total of 125,000 tonnes of waste in 2017. This amount is expected to fall by 2% each year. So we're to decrease is to be reduced by 2% each year. Calculate the amount of waste in 2020. Okay, so first of all, quite often in these questions they say after 3 years or after 4 years. So just remember, we're talking about 3 years then, okay, because it says that's the amount in 2017. What is it 3 years later? Right, okay, so this is a percentages question. We're going to start with 125,000. There's a couple of different ways you can do this. Remember, if your teacher showed you to do it slightly different, just do it your way and just double check you get the same answer, okay? So if I was doing this question, we're working out a future value, so we multiply. We're not increasing. If we were increasing by 2%, I'd multiply by 1.02. We are decreasing. So it's like taking 2% off. So I'd be multiplying by 0.98. Essentially, 100% take away 2% is 98. And now it's to the power 3 because we are doing this for 3 years. Okay, so key into your calculator. Gives you, let's see, 117,649, and then we'll go back and check the question if it mentions anything about rounding. It doesn't mention about anything about rounding at all, so this is just tonnes. Okay, always try to remember to write down your units as well. Right, number 2. Here's the sector of a circle. The radius is 7.4. Calculate the length of the arc. So it's an arc length question. This formula that I'm putting here, remember, for the arc length is not given on the exam paper. You should know this. So the arc length is the angle over 360 times by. Now, the arc length, is it part of the circumference or is it part of the area? The arc length is a bit of the circumference, so it's pi d, the circumference formula. So for this question, it's the major arc, so it's the big outside arc. So the angle is 320 over 360 times by pi and times by the diameter. The radius is 7.4. What's the diameter? Double that. 14.8. Let's key into the calculator. Remember, you should be using the pi button. On my calculator, I get approximately 41.3. And remember, let's have a wee look about rounding. Does it mention anything? It doesn't, it just says calculate the length of the arc. So 41.3 is fine. If that number after the 3 was a 5 or more, I would not be able to leave it as 41.3. I'd need to bump up to 41.4. Right, so round sensibly, I tend to go for 1 decimal place. Put the units in. It's the length of an arc. It's a distance. It's in centimetres. Okay. Find the magnitude. Right, the magnitude of a vector is it's built in. It basically ties into Pythagoras. Okay, it's like working out the length. How do you do Pythagoras? You square the other two sides, add them up, and take the square root. That's what you're doing, except you're squaring all 3 numbers. Square them all, get the total, and then you're going to basically take the square root of that number. Okay. 576, 144. Remember, when you square that negative number, it is going to be a positive number. Okay. Let's see. Add 144 and 64. Square these up. It gives you 784 when you get the total. Take the square root, because that's how you work out the magnitude. 28. Okay. Remember, what I'll do is I'll do screenshots of this at the end, and I'll put them up as well. Okay. Number 4. Solve the inequation or the inequality. I'd get rid of the brackets first of all. Multiply 6 times x. 6 times minus 1. So all I've done there is I've removed the brackets. Okay, now we've got x terms on both sides of, well, I was going to say the equal sign. Remember, we're really treating this as an equation. Solve it as an equation, but just be careful. There's a couple of things you need to remember. Now, I'm going to do it the way that most people, I think, would have done it. Okay, most people will bring the x's onto this side. So I'm going to do it that way. Okay, 3x take away 6x is negative 3x, is less than negative 18. Now, at this point, what we're doing here is we're dividing the negative 18 by negative 3. Now, there's something you have to remember. When you divide by a negative number, and hopefully you remember now that I've pointed it out, what happens is you must reverse the inequality symbol. So the answer to this, just tidy that a wee bit up a bit, is x is greater than, not less than. Because we're dividing by negative 3, you reverse the inequality symbol. 18 divided by 3 is 6, so negative 18 divided by negative 3 is positive 6. Okay, negative divided by negative is a positive. Number 4. Find the mean and the standard deviation. So these numbers represent the number of customers who visited their stall on a Saturday. So we have to find the mean and the standard deviation. Sometimes it might just say work out the standard deviation. If it does say that, you still need to work out the mean. Okay? Right, the mean. We add them all up. Get the total. And divide it by 6, because there's 6 numbers. Just take your time keying these numbers in. I am expecting a whole number. It's not always the case, but most times it is. Okay, if I get a decimal number here, it actually makes the standard deviation a bit more difficult and a bit fiddly to work out. So we tend to always get whole numbers. Most times. And I bet this works out as a decimal after me saying that. 756 is the total. We're going to divide by 6 because there's 6 numbers. Divide by 6 and it's 126. So as I said, see if that worked out as a decimal number, it makes the standard deviation a lot more complicated, and chances are they don't tend to do that, okay? So if you get a decimal number, I'd go back and look again. Right, the standard deviation then. This is where we need to set up a table. Well, I'm going to fit it in here. I'm going to move that over a wee bit. 756 divided by 6 equals 126. Just to give myself a wee bit of room. There we go, it's much better. Right, so we're going to set up the 3 columns in the table. The numbers that we were given are down the left hand side. Okay, now the middle column, this is our difference column. I like to remind myself by the letter D. They don't need headings, but if you remember the letter D, it might help you remember it's the difference. So in this column, what we put is the difference between each number given and the mean. The mean was 126, okay? So the difference between 120 and 126 is 6. The difference between 126 and 126 is 0. The difference from 125 is 1. Okay, the difference between 131 and 126 was 5. Each of the differences I'm putting in. The difference between 124 and 126 is 2. In the third column, we square these differences. So I put d squared, just as a wee reminder, the difference is then squared. So take each number and square it, times it by itself. 1 times 1 is not 2, 1 squared is 1. You can use your calculator, remember, you do have a calculator for this. So that's my squared differences. Now, the last couple of steps, we add up the total. Add them up. 82. Okay, now there's still a couple of steps left to work out the standard deviation. We take the number 82 and we divide it by something. I'm hoping you're thinking the same number. The correct number is we divide by 5, not 6. The reason we divide by 5 is to be divided by 1 less than how many values you've got. That's why it's a 5. So I'm going to divide this number by 5 and it gives me 16.4. That is not the standard deviation yet. The standard deviation is now the square root of that number. Take the square root of that number and it gives me about 4.049, blah blah blah. Just double check, does it mention anything about rounding? I don't think it did say, so I'll leave it as 4. Okay, but it doesn't mention anything. Right, part B. The mean number of customers on Sunday was 117 and the standard deviation was 6.2. Now we have to compare them. Well, first thing I'm going to do is write down the numbers. So we've got the mean and the standard deviation. So in part 1 it was Saturday's numbers, that was part 1. In part B these are the values for Sunday. So on Sunday the mean is 117 and the standard deviation is 6.2. You don't need to set it up as a table like this. I'm just putting the numbers here together because they're on the last 126 and 4. So in part A we got the mean was 126 and the standard deviation was 4. So we have to compare these. Now remember, we're not allowed to say the mean for Saturday is higher, right? The number is higher, but we need to see what that actually means. Okay, so we can say the mean is higher on Saturday, but what does that actually mean? Well, remember, these values were how many customers were in a stall, okay? How many customers visited the stall. So because the mean is higher, that means there were, on average, more customers on Saturday. Or you could say, remember, the mean on Sunday is lower, so there's less customers. Doesn't matter which way you put it. Right, that's a comment about the mean. Now we need to make a wee comment about the standard deviation. So the standard deviation, will we go with, we could say the standard deviation on Saturday's lower or Sunday's higher, as long as we put the correct statement. Remember, the standard deviation is a measure of how widely spread out the numbers are. Okay, it's a measure of spread. So we could say the standard deviation is lower on Saturday. It's lower on Saturday. What that means, what that really means is the numbers of customers, because it's all about the number of customers, are less varied. You could say something like that. Less spread out. Or you could say, or the number of customers are more consistent. Less varied, less varied or more consistent. It doesn't really matter which way you put it. Okay. Number 6. Here's a function. F of x is 5 plus 4x. F of a equals 73. Find the value of a. Right, this is not where you sub in 73 for x. Okay, if the number 73 was inside that bracket, you would sub in, you'd replace x by 73. The letter x is not in the bracket, or the letter 73 number, 73 is not even in the bracket. It's a letter A inside the bracket, so that means it's a letter A that's replacing the x. But it's equal to 73, so that's why we're putting it equal to 73. It's really just a mini equation. A's, keep them on one side. Put your numbers on the other. I'm going to move the 5 across and take it away. gives you 68. Now if 4a is equal to 68, what do we do? 68 divided by 4. And remember, it's a calculator paper, but I'm sure most of you would be okay with that. E works out as 17. Number 7. Toy company makes spheres. Here's the sphere. The diameter is 6.4. Find the volume. The volume formulas, remember, I'll just... There, it's there. Okay, formula list. This is here, it's the volume of a sphere. So the volume of a sphere formula is somewhere. Yep, there it's there. 4/3 pi r cubed. 4/3, 4 divided by 3, times pi, times the radius cubed. This is the diameter, so remember that means the radius is actually only 3.2. The radius is half the way across the circle. Cubed. Key into your calculator. 4/3 I would key in as 4 divided by 3, times by pi, times by 3.2 cubed, or to the power 3. When I do that, I get 137.258. Okay, and now what I would do is I would go back, double check, does it mention anything about rounding? It does, it says 2 significant figures. 2 significant figures means the first 2 digits are the most important 2 digits. Check the next one. The next one's a 7. Is it 5 or more? Yes, it is. So we're not going to leave it as a 1 and a 3. The 7 is going to bump 3 up to a 4. So 140 is what this is. Remember that was 137. Okay, 140 units, volume, distances in centimetres, volumes cubed. That is a 3. Okay. Number 8, solve the equation. So this is a trig equation. If it was a normal equation, you'd be looking to put your x's on one side and your numbers on the other. It's the same method that you use for trig equations. Sine x plus 2 is equal to 3. So we do 7 sine x. First thing we do is move the plus 2 across. Where does it go? Onto the other side and becomes a subtraction. So really what we've got is 7 sine x equals 1. Now, how do you find sine x then? If you know that 7 sine x is equal to 1, what do you do with the 7? We do a division. 1 divided by 7 on my calculator is 0.142. Now remember, what is x? Solve the equation. X is an angle, okay? Let me just fix that. That's a 0 point. 0 point, that's better. Right, this is trig equations. We always get 2 solutions for our trig equations. How do we get 2 solutions? Well, one solution comes from the calculator. Let me get the first for us. We do the inverse sine of that number that's on the calculator. I would keep the number on the screen and hit shift or inverse, second function sine. It comes up sine to the minus 1. And I get 8.2. Does it mention anything about rounding? No, I'll leave it as 8.2. Now remember, we're getting 2 solutions. We need to double check. This is where you're thinking about possibly, you may be thinking like this. Or maybe you're thinking about a cast diagram. Again, it depends which way your teacher has shown you how to do this. Let me just check. Right, so we've got sine was positive. 0.14 is a positive number. So we're going back up to this bit here. Sine equals, and it's a positive number. So sine is positive. So all of them are positive in the first quadrant. Sine is positive in the second. Tan and cos are positive in the third and fourth. So which 2 quadrants is sine positive? It's the first and second. So the first quadrant answer comes from the calculator. So that is our answer, 8.2. That's our first quadrant answer. How do you get the second quadrant answer? Well, you do 180 minus the first quadrant answer, which is 171.8, we'll say. Doesn't mention anything about rounding, so that'll be fine. Okay, these are actually x, they're angles. You wouldn't lose a mark if you didn't put in degrees though, so don't worry. Number 9. Angle, right, okay, 75 degrees, 37, 20. Find the length of DC. I'm just going to put that as a letter X, okay, that's the one we've to find. Doesn't look like a letter X, there we go. Right, sine rule, cosine rule is one of these questions. I'll bring up the sine rule and I'll bring up the cosine rule. And I'll just leave it here at the side. There we go. I'll do it. Right, let's see. Do we have an angle and a side across from each other that we know both values? Yes, 37 is across from the 20. So because we've got an angle and a side across from each other, that pretty much indicates we can use the sine rule. We can actually use the sine rule. Okay. However, to work out side x, we'd need to know that angle in here. I can work out this angle. See the wee one that's just below the 75? Well, A down to C is 180 degrees, so 180 take away the wee 75 gives you 105. So that angle in there is 105. Okay, 105. So, sine rule. Side A over sine A is equal to side B over sine B. Remember, the little letters at the top represent the sides and the capital letters at the bottom represent the angles. Okay, I would always put x, the value that we're trying to work out, I would always put x on the left hand side of this formula. It's just the way that I've always done it, and it's the way that I've shown my class. So x, is it a side or is it an angle? X is a side. And at the bottom we put sine of the angle across from it, sine 105. On the right hand side of this formula, I'm going to put in 20 is the side and sine of the angle opposite, sine 37. Okay, nearly there. Now to find side x, the value of x, we don't want that sine 105 at the bottom. How do we make it disappear? Where does it go? It goes on to the other side. Sine 105 is on the bottom. It's a division by sine 105. The reverse is we're going to multiply it by sine 105. Okay, key it into your calculator. Remember, we're not pressing inverse sine or anything like that here. It's just sine 37. When I key that in, I get approximately 32.1. And we'll just double check, go back, see if it mentions anything about rounding. It doesn't mention anything, but we will put in that this is in centimetres. Number 10, this is the last one I'm going to do, and then please stop the video, or it'll stop itself, obviously. Go back and try the questions that I've created for you, and then come back and watch part 2. Right, okay, vectors. A to D is 2 times A to B. Right, okay, so A to B across the top is vector U. That means, given this wee bit of information here, this one must be 2U then, because it says it's 2 times the top one. 2 times AB, so it's 2U. This wee bit here, the next one, E to A, which is this one here, which is W, that's 2 times the size of DC. It's not saying that DC is 2 times the size of W, right? W is 2 times the size of this one here. What's this one here then? This must be a half of W. Okay, if that's a half of W, then E to A is 2 times that one, which is W. Okay, right, let's see. Express B to C in terms of, right, okay, so I'm going to change the colour in here. Right, B to C. Right, basically what we have to do is show how to get from B all the way to C. Now we can't go like that because, well, we don't know this. But we go along the sides that we do know. Okay, so B to C, starting at B. So we're going to go this way. Now you'll notice that's a vector U along the top. However, the arrow's pointing the wrong way. If we're going in the opposite direction, I'm hoping you're thinking right, we do a change of sign. So it's a negative U at the top. Then we're going to go down this way, and again, It's the opposite direction. Vector W is going upwards. We're coming down the way. Right, we're basically going along the way, down the here, across the way and up here. So we've done negative U, then we need to do negative W. Then we're going from point E all the way across here. The arrow's pointing in the right way, so that's good. We're not doing negative. Just need to add on to U. And then the last bit, we're going upwards, and the arrow's pointing in the right way. We're going in the right direction, so we're just going to add a half of W. Let me just tidy that up. That's a U in there. Now, we're not allowed to leave it like that. Tidy it up a wee bit. Collect the U's together like algebra. We've got 2 U's. Take away U. So we've only got 1 U then. And then the W's, that's negative a W. Negative 1, remember? But we've to add a half to it. So negative 1 plus a half. Negative 1 add 0.5 leaves us with negative a half. You can write negative a half W, or you can write negative 0.5 W. It makes no difference. Okay? Right, so as I said, try the questions that I've provided. They do match up to the ones that we've provided here, okay? Best of luck, and remember, I will be on live on the Teams at the time when you're doing this, so please come on and ask for help. Right, bye-bye.